So now I want to go ahead and import a model so I can show you the other functions within OpenBio. So you'll notice I already closed our project. I'm going to make a new project and call it Demo 3. And then I'm going to go to File, Import, SBML file to OpenBio with unit conversion. And I'm just going to select a circadian rhythm clock model that I downloaded off the internet. This is the 1995 gold beater model of the pure protein becoming phosphorylated. Now, as soon as you import a model, you'll notice that the 4 panels I showed you before, the species, reaction, parameter, and pathway diagram, are now populated. So here's all the species within the model, here's the reactions, and here's the parameters and their associated values. And now you'll notice the pathway diagram is now populated with a rough topology of the model. So now what we can do is we can go through the other functions that are available in OpenBio in the left-hand side of the window. So here you see under Mechanism is Parameter Set, Computations, and Experiment. So I want to start by going to Computations because the first thing you want to do when you import your model is to simulate it. So under the Computations tab, we have 3 sub-tabs. So we have Simulations, Global Sensitivity Analysis, and Estimations. So I'm going to click on Simulations, and you notice there's already default simulation in place. If I double click that, it brings up some properties I can edit about the upcoming simulation, most notably the simulation time, which is shown here. So what I'm going to do is I'm just going to load some default values in it into the simulation, set it. I think my time is good at 100. And then I'm going to right click on this and say execute simulation. And you'll notice the simulation occurred very quickly. The time to instantiate it and actually run the simulation for 100 seconds took 0 seconds on this computer. So it's a small model, but OpenBio has one of the fastest numerical engines available today. So now that the simulation has been run, we want to right click on that simulation again and view the output. Now what you'll notice is that a 4-window results viewer comes up. So this is called the Simulation Explorer, and these 4 windows are as follows. So in the upper left we have the species summary, so these are all the species within the model. On the upper right we have all the reactions in the model. In the bottom left is the graphing window where we'll see our time-dependent trajectories, and in the bottom right is our animated flux diagram. So let me show you how this works. So these 4 windows are dynamically connected to each other such that updating one of the 4 windows will dynamically update the other 3. So for instance, if I want to see what happened during the simulation to unphosphorylated, monophosphorylated, and biphosphorylated PER, I simply click their checkboxes and hit the update button. And you'll notice that the time-dependent trajectories for those 3 species are now shown in the graphing window. And as I mentioned, this is a circadian rhythm model, thus it has a periodic nature to the model output. The reactions that contain those 3 molecules are then shown in the reaction summary window. So for instance, if I deselected a few of them, update again, only the reactions showing biphosphorylated PER are going to show up in the reaction summary window. Similarly, the selected species is also shown in the animated pathway diagram window. And this is one of the key features we think to viewing and understanding models. This animated flux diagram viewer will show you information flow through your model dynamically as if the simulation was running. So let's see. Simply click the plus button and then start the animation, and what you'll notice, you see the sizes of the nodes changing, implying that their concentrations are changing. And you notice that goes right along with the graph to the left, the periodic nature, the concentration of the species going up and down. Again, this is not only good for understanding model topology when you're building and debugging models, but especially when you have a model that you already know the structure is correct and you want to start to extract insight from it. So where is the information flowing in your model? Why are species concentrations high at this time versus not at that time? Are there limiting reagents in your model? This is a really powerful visual way to see what's going on in your model. With that, I'd like to conclude. the first video tutorial on building and importing models and simply viewing results. The continued tutorials will cover the rest of the functions within OpenBio, including global sensitivity analysis and parameter estimation.